Hey, everybody. This is a session on variables and simple data types. So let's go ahead and jump into it. So what are variables? Variables are containers or references to information. They have a name, a data type, and a value. Given the image on the right here, I have a green box. So imagine a literal or a physical box, and I'm putting the label score on it. So that's me naming a variable score. Then I'm putting the number 2 inside of my box. So therefore I'm assigning the value 2 to my variable score. And then the data type is inferred here, but it would be a number, right? Or more specifically, an integer, because 2 is a nice whole number. It is not a fraction or a decimal, so therefore it's an integer. So in this case, I have a variable score with a value of 2 and a data type of number. So let's take a look at some examples of some variables in code. So the syntax for it is the variable name equals whatever the variable value is. So first we have score equals 2. So that's exactly what we just did on that previous slide with the box, right? We have score equals 2. Then we have deposit equals 100.23. This is a decimal or a float value in Python. Then we have my name equals quote will. This is a string which contains text. Is available equals false. Now notice here, this doesn't have any quotes around it, right? And that's because this is a Boolean, meaning it has to be either true, capital T true, or capital F false. That is a specific data type in Python, which is why it does not need the quotes around it. But we'll get more into the strings later. So some syntax around variable naming. So names can only contain letters, numbers, and underscores, and they can only start with a letter or an underscore. They cannot start with a number. Spaces are not allowed. So for example, I can say user underscore name, but I cannot say user space name. You want to avoid using Python keywords and function names as variable names because that might be confusing. These keywords and the function names there are both links to their respective standard library documentation. So feel free to click on those and take a look. And then not a syntax thing, but try to keep your variable names short but descriptive. So for example, total underscore score. It's pretty reasonable to assume what that variable is doing, even given no context about the program. Then we have TS. I have no idea what that would be doing in a program without any context. So that's a terrible name. And then we have the player's cumulative score so far. Okay, I can pretty much guess what that's doing without context, but it is very lengthy, right? It's a lot to type and it takes up a lot of real estate on the screen. So probably not the best name there. So total score is an appropriate name. And then again, not a syntax thing, but Python programmers generally prefer the underscore or snake case versus camel case. So for example, user underscore name, that is your snake case, versus user capital N name, right? That is your camel case. So in camel case, the first letter is lowercase, and then every word of the variable has a uppercase letter. So Python programmers generally prefer the snake case, whereas languages like Java and C# are going to prefer that camel case. So during my lectures, I'll say something along the lines of pause the video here, take a look at what I'm asking you to do, attempt to do it, which in this case, there's no code to attempt to do, but there's some question, right? So go ahead and try to answer this. Pause the video, try to answer it, and then we'll continue on. Okay, so here's the answers. So score equals 12. This is going to work. There's nothing syntactically wrong with this. However, it is a bad practice to start with a capital letter, right? So the capital S there. My underscore score equals 25.0. This is good. Player space 2 equals will. This is not going to work because you can't have spaces in variable names. Underscore total equals 124.99. This is okay, but variables that start with underscores have a very specific use case in Python, and that's well out of scope of this particular series. But if you get into object-oriented programming with Python, it'll start becoming relevant. 1_player equals Sam. This is an error because you cannot start with a number. So what are data types? So data types are used to categorize a piece of data. So I kind of mentioned these terms already, and that was kind of getting you prepared for this particular slide. So there are four data types, or four simple data types that we're going to be looking at. So we have integers, which are whole numbers, floats, which are decimal numbers, Booleans, which can only store a true or a false, and again, capital T, capital F, and strings, which can contain text. So starting with integers, integers can do basic arithmetic like addition, subtraction, multiplication, and division. And Python uses two multiplication symbols, or two asterisks, to represent exponents. So 3 asterisk asterisk 2 is going to output 9. Python follows the order of operations just like your regular math classes have taught you. So 2 plus 3 times 4 is going to output 14, whereas parentheses 2 plus 3 times 4 is going to output 20. Just something to be aware of, when you divide two integers in Python, it will always give you the answer as a float, right? So 4 divided by 2 is going to output 2.0. This is because Python doesn't know ahead of time whether or not this thing is going to be evenly divisible. So therefore, it just automatically converts everything to a float regardless. And then something that's kind of nice about Python is that large numbers can be written using underscores to help with readability. I don't know about you, but when I type out the number 1 million, I type 1 and then I go 1, 2, 3, 4, 5, 6 on the 0 key. I count it out as I type it. So just something that's kind of nice about Python is that you can use underscores instead of the commas to kind of separate those zeros out and make it a little easier to read. Floats, very similar operations to integers, so all the same things as far as arithmetic, addition, subtraction, multiplication, etc. But something to be aware of is that sometimes floats are imprecise. And for our purposes, we're just going to ignore this. So an example would be 0.2 plus 0.1 is equal to 0.3000 repeated all the way to 4, right? We're just going to ignore this for right now. Just realize that if you see something like this, it doesn't mean you necessarily did something wrong. So here is a table that I have shamelessly stolen from the Python standard library. Excuse me. On the left side here, we have an operation column, and this is just what the Python code might look like. So given a variable of x and a variable of y. So first we have x plus y, this is addition, x minus y, subtraction, x asterisk y, that is multiplication, x slash y, that is division, x slash slash y. You may not be familiar with this particular syntax. And what that's doing is it's called floored division, meaning it will round down to the nearest integer after the division. Then we have x percent sign y, and this is going to give you the remainder of a division, right? So say, for example, I've got x equals 10 and y equals 3. So 10 divided by 3 leaves me with a remainder of 1. And that's what I would get if I used the percent sign. Negative x is just changing whatever x is to a negative. Plus x is kind of irrelevant. We're going to ignore ABS for right now and move to the int and float, those last two in that big red box that I made there. So int parentheses x. So whatever goes in the parentheses in this case, which in this case is x, it will attempt to convert it to an integer. So for example, let's say I ask the user to enter their age, right? So let's say the user entered 50. Well, in Python, when you get user input, it always gets read in as a string. So that's why this particular function is important, because you get the user input as a string and then say, okay, I'm now going to convert that to an integer to do maybe mathematical operations or whatever it is you want to do on that number. And then we have an equivalent for float as well. So it's float parentheses x or whatever goes in the middle there. And it's the same thing, right? If you ask the user to enter a deposit amount, right, and they enter 99.99, it's still going to get read in as a string. So you have to convert it to a float. And that's what this function is used for. I have a link over there on the right side, Python standard types. So feel free to click that and take a look at the standard library. When it comes to strings, so strings can store text data, but as I said, they can store the user input, right? So I said they could store the number 50, or they could store 9999, or whatever the case may be. So strings can really store whatever. Anything can be considered text data. But for our purposes, let's kind of continue on here. So strings are indicated with a double quote or a single quote. So Python is one of the languages that's a little flexible in this regard. So some examples are double quote, hello world, end double quote, or a single quote, hello world, end single quote. And unlike integers and floats, strings have helpful built-in methods or functions. So here's a few of those functions. So we have dot upper, dot lower, dot title, dot is alpha. And there's a lot more, and there's a link there to W3 schools. Take a look if you're curious. But the upper is going to convert all the letters of a string to uppercase. The lower is going to convert all the letters to lowercase. Title is going to convert the first letter of each word to uppercase. And then is alpha is actually going to return a Boolean, so a true or a false, depending on whether all of the characters in a particular string are actual characters, right? So alpha characters. So taking a look at this particular screenshot here of some code, I've got a variable my name equals, and this is a string as indicated by the quotes, right? So William Estes, right? And it's capitalized in a whole bunch of different things here. So, but it's to demonstrate what these things are doing. So on line 2, we're saying print my name dot upper open close parentheses. So once I run that function, it gives back a uppercase version of my string, and therefore you see it in the output, all caps William Estes. Then we move to my name dot lower, right? That's going to give back a lowercase version of my name, and then we see that on the second output there. So William Estes as all lowercase. Then we have print my name dot title, and that's that third output. So capital W and capital E. And lastly, my name dot is alpha, right? Now you might have thought this would produce true, but it's producing false because there's a space, and the space in William space Estes is not considered a alpha character. Therefore, it produces a false value. And that's all I had for this first session. So next time we're going to be looking at complex data types. So feel free to reach out and ask questions, but I will see you next time.